Hello again. Welcome to chapter 6, where we shall be concerned with other data types. So far, we have been dealing with integers. Now, we have not experienced the treatment of other numeric variables such as floats, where we can have decimal numbers, or double, where we have decimal numbers which are even longer. We have not seen the use of characters or strings, where we can deal with types like names and so forth. So integers are whole numbers, as you have seen, 0, 12, minus 100, whatever. But then floats are numbers with fractions such as 0.7, 12.99, minus 100.89, etc. Now, with floats, the decimal part is limited to 6 digits, such as this number here. And when we have a bigger number or a number with longer, more digits on the decimal part, we use double. Now, this is a piece of code where we have float x, float y, float z, because this is the keyword that we use to declare such variables. And in x now we can assign this value, in y we can assign this value. Now z can take this summation, and in that regard we can see now some results with decimal figures. Let us go and see how such a program will work in a real environment. This is a program, include as usual, using namespace as usual, int main, starting from this particular bracket, ending here, returning 0. But now, let's see here, float w and p. Two float variables which can contain decimal numbers have been declared, and this is another variable of float type. Here we are getting the message enter two integers. If you enter, let's say 7.8, it will go to w. If you enter 8.9, it will go to p. But here we are getting operation w divided by p, and here we wanted to see the answer that is stored in B. Let us compile this program and see what happens. It's okay, there is no error. And if we run it, let us enter 7.89, that's the first number. We can enter 4.888, and now we are getting an answer that is 16.1579. So now we are dealing with the decimal numbers instead of dealing with just whole numbers. So that is as far as other data types are concerned. We could come here, and if we want, we can declare a character, char. We could say chara, let's say, and then we can say now cin, wcin p. But then here we can say cin, let's say a. But before we treat that one, we must put a message here and say cout, enter a character, so that we know what kind of data we are going to enter. End of line. Now, so when the computer comes at this point, we will have a chance of entering a character. But if we want to see it, we can come here and say cout and say the character, let's say the character entered is the character entered is, let us see, and if we close here and we say end of line, Then we want to see it here, see out, because the character was entered in A, we wanted to see A, and that would be it. Let us compile and see how the program behaves. So far, there is no error. Let us run. Enter two integers, 4.7. I may enter 34.98. Enter a character, I can enter R. So I am seeing here the quotient is, this is the result of division, the character entered is R. So this is the R that I entered here. So far, that is how other data types are concerned. Let us now go and see how this particular program can be visualized in order to understand better the scenario. Now, as usual, before declaration, this is the RAM. Nothing is inside. But after declaration, we are going to assume that for every size of integer, we need actually a bigger RAM. So this is going to be a bit longer. So the RAM is going to be a bit longer. When we have, let's say, W and P reserved, that is a float, this is reserved. And then we have character, a float B, these are reserved. We can just go on and on. But now, let us, because this is a bigger portion of memory, let us assume that now for the rest, the memory is going to be just as we can look at it there. So far, this is as far as memory allocation is concerned. So reservation is done for W, which is a bigger, sort of a longer memory space. P, because it is float, is a bit longer than the integer, and even B is a bit bigger than the integer, but the rest is free, and the free part is just on the conventional size, the normal size. So this is after float W, float P, float B. Now character A, it means here, this is variable A. So we can say now, this now is reserved, but it is of the size of integer, because even the characters have got 8 bits. Now then, after C in W, C in P, the memory will change. We are going to see a situation where this memory is going to change a bit, and we will have we can put 8.777 or 8, and we can put 1.66 or 5, whatever, and then this one, that is B, will still be reserved. And on the other part, when we are dealing with this kind of, let's say, we have the other part where A is reserved and the rest is free. That is after data entry. Now, after the operation, that is this line here, B equals to W. That is B equals to W over P. It means B, this particular memory here, is going to be assigned. This is W, and this is P. B equals to W over P. Let us put it properly here. B equals to W over P. W over P. What happens is that 8.77778 will be divided to 1.665, and the answer now will be stored in A. Let us see what comes out of that. So the situation will be W, we have 8.778. We have 1 in P, 0.665. And now the result here, we will get, let's say, 1. For that matter, we are going to get something like this. Will be, if we put 5 here, that will be 10, and then we have 30. They are going to carry 3. It will come to 8, but it will be some 4 point something is going to be stored in B, that we will see. However, concerning A, then we have C in A. A here, sorry, after entering these values, A, this line here, C in A, would be executed. I forgot it. Would be executed, and instead of R there, it means we are going to have the value of let's say we have entered, let's say, character J. So here we would have J, and this would be A, while the rest would be free. Now when you see out, you will be see 4 point something there, and then you would see J as a character. So this is more or less visualization of the way other data types are implemented in programming. For now, I have to thank you and say bye-bye.